Python has an elegant implementation of the hash table called the dictionary. It's used internally in many places, not the least of which are global and local namespaces. They are also used to keep track of an object's attributes. You'll find many uses for dictionaries yourself, and thanks to their order one behavior, they'll be useful for large and small data sets. A dictionary is a hash table. A hash table is a computer science concept that allows you to map keys to values by storing key-value pairs in an array in an optimized way such that you can quickly find any entry by its key. This requires that the key be hashable, as a dictionary uses the hash function to calculate where the key should be stored in the array. Python calls the key-value pairs an item. I'll try to be consistent in this video and refer to this as an item rather than an element. Note that the key must be hashable, meaning that you can pass it to the hash function. Hashable objects typically include any and all immutables in Python. The hash function will always return the same value for two objects to compare equally. For instance, if you take the hash of the integer 0, that should be equal to the hash of the float 0. It is possible that the hash function will return the same value for two unequal objects, but this is very unlikely. You can also hash tuples. Each item in the tuple must also be hashable. Remember, any immutable object in Python is likely hashable. So here's an example of what you might do with a tuple. So you can do 1, 2, and 3 inside the tuple and hash that. So the tuple 1, 2, 3 is a valid key. Python dictionaries are described in the following syntax. So if you have an opening and closing curly bracket, that is an empty dictionary. Inside of the brackets, you can put key-value pairs. You're going to separate the key from the value with the colon. And you can have as many of these as you want. And you can optionally end on a comma. It's not necessary, but it's optional. It's important to note that the key is an expression. So this is not just a string, but an expression. Typically, it is a string, but if it were to be a string, you have to actually put quotes around it. You could also include a variable or an expression that resolves to some immutable value that will be used as the key. Here's an example of a simple dictionary that uses strings as keys. So we're going to have cow maps to moo, and we're going to have sheep maps to baa, and pig maps to oink. The value can, of course, be anything, including a list or a tuple or even another dictionary. The value does not need to be hashable or immutable or anything like that. So we can have a dictionary, I'll write it over here, where we can say that the tuple red, comma 27, maps to a dictionary, which is mutable, obviously, that has blue as a key and the value is 19, and it has orange as a key, and this has a value of the mutable list 1, 2, 3. And we'll close off this guy, and then we'll close off that guy. It is considered good practice to have dictionaries that only have one common type for all the keys and one common type for all the values, but this is not a requirement in Python. It's not uncommon to see people violate this rule for various reasons, and you'll uncover some reasons why you might want to do that yourself. Importantly, if two keys compare the same, then they are considered the same key. For instance, if I created a dictionary like this, and I said 1 is bird, and 1.0 is also cow, well, 1 and 1.0 are actually the same value. They compare equally. And so it's only going to store one key, which is 1, and the value will be cow, the one that shows up next. So it is possible to specify more than one entry with the same key. It'll keep the one that's last. As for list comprehensions, you can also write dictionary comprehensions, and as you might expect, they start with curly braces. However, the comprehension inside is slightly different because instead of a regular expression, you have to have a key-value pair specified. Everything else about the comprehension is the same. As it is for list expressions, this will create a new dictionary with values generated from iterating across the loop and substituting in the key-value pair for that. In Python, you can also have double star expressions. So if we had a dictionary, let's say this is A, is 1 goes to A, and then we want to create another dictionary. This one will say 2 goes to B, and then we're going to do double asterisk A. And what this does is it includes the keys and values from this dictionary in this dictionary. And so B will have 2 going to B and 1 going to A. You can have as many of these as you want in any order, and you can even put key value pairs in between or after them if you like. So here's an example of a dictionary. So we can say Z is 26. We're going to include A, and then we're going to say old is new, and then we're going to include this, and this is kind of silly to do it this way, but this is what we're going to do. This is perfectly legal in Python. So we create a dictionary and then include it in line, and then finally we're going to include 27 goes to 19. So you see you can include these as many times as you want in any order. If you end up specifying the key more than once, the one that appears last will take precedence. Let me remind you that for lists, you can do something similar. So you can have 1, 2, and then have another list included, 3, 4, and then another list goes here. So you can do that as well for lists and sequences and tuples and everything else like that. You could include a dictionary, as I did here, and what this will actually do is this will iterate over the keys. So this is the sequence with just the key 1, and this will be the sequence with 2 and 1 in it. When calling functions with named parameters, you can actually specify a dictionary that has those arguments in them and use the double star syntax as function parameters. So function arguments. So we might have args is equal to key is int and reverse is true. And then when we go to call sorted on some sequence S, we can actually do double star args. And it'll include the keys of the dictionary as arguments to this. The dictionary obviously needs to have at least the keys are all strings. They don't necessarily have to be valid identifiers, but they do need to be strings. Okay. When you're specifying a function, you can receive any number of named parameters. So that would look something like this. So we have some function, and we have double star kw, and I typically call it kw args. And so here, this function will just accept any named parameters that you can come up with, or even if you pass in a dictionary, anything that's a string, it'll accept it as a parameter. You can't specify any named parameters after this, but you can include them before. So here's an example of including named parameters before it. So we might say name equals none, and then we end with star star keyword args. And in this case, what it would do is if you specified the name, then it will use that for the name. If you don't specify the name, then it'll be none, and the rest of the arguments will be stored in keyword args. Okay, and you'll typically see functions defined this way, where you have star args and then double star kw args. And what this does is allows any number of ordered parameters or named parameters to the function. You'll see this typically when you write decorators. There's not too many operators that operate on dictionaries. I'll list the ones that you should know about. We have k in D, and that tests that the key k is present in the dictionary. It doesn't check the value, it just sees that the key is there, so the value could be none. You also have k not in D, which does the same and makes sure that key is not in the dictionary, whether it's none or not. You can do subscription, so you write D and you pass in the key as in the square braces, and this will raise a key error with capital E. Key error if missing. Otherwise, it will return the value. You can also compare two dictionaries and see if they're the same. This will check that all the keys exist in both dictionaries and they all have the same values. And you can do not equals as well. And this makes sure that either there's keys present in one but not the other, or the values for the same key are different. Dictionaries don't have a slicing syntax. It's kind of hard to know what that would even mean. If you tried to pass a slice into a dictionary, it'll give you a type error because slices are not hashable. You can assign to dictionary subscription as well. So let's say we had an empty dictionary here, and then we said D of A. So we're going to use A as the key, the string A as the key. We're going to set that to 1. Okay, and now the dictionary has a single key with the value of 1. Note that A wasn't previously in the dictionary. This is not an error when you're assigning to it. And then you can override that later if you wanted to. So now in the dictionary, the key A will have the value 2. The only error you might see is if you try to use a key that's unhashable. You'll get a type error if that happens. You'll never see exceptions for key error or anything like that, unlike lists where if you assign to something outside of the list, it'll cause an error. And of course, you can't assign to dictionary slice. That doesn't mean anything in Python. You can even remove elements. So you can use a del statement. So this will remove the key A from the dictionary. If A is missing, this will raise a key error. There are a few built-in functions in Python that deal with dictionaries. Obviously, there's the dict function. With no parameters, it will return a brand new dictionary. You can specify some dictionary, and you can also pass in keyword args. And what this will do is it will copy the dictionary D, and then any keyword args you specify will be overridden for the key value pairs in the dictionary D. Okay? You can also create a dictionary from a sequence and additional keyword args if you want. In this case, the sequence should be of key value pairs. You can take a length of a dictionary. That will tell you the number of keys in the dictionary, whether the values are none or not. And you can also iterate across a dictionary. And this will just by default iterate across the keys of the dictionary, not the values. There are two other functions that are interesting. One is called globals. And this returns a dictionary with the global variables. And there's also locals, which returns a dictionary with the local variables. Don't try assigning to that dictionary. It may not have the intended effect. There are quite a few dictionary methods, and you should know them all. They're not that hard to understand and use. Let's talk about these three. So there's d.keys, d.values, and d.items. I need to spell better. Okay. All three of these return something called a dictionary view. That is, they don't actually copy the keys or values or items of the dictionary. They return an object that you can use to iterate across them. In the case of keys, that object, when you iterate across it, will give you each of the keys of the dictionary. The values will give you each of the values in the dictionary, and the items will give you key value pairs. Here's some code that'll help you understand what's happening. So let's say we have an empty dictionary, and then we say values is equal to d.values. Then we update that dictionary, setting red to be blue. There's no quote there, it's just the keyword red. Now, if we were to create an array that's a list of those values, this array would just have red, or blue, I'm sorry, it would just have blue. And then if you were to update the dictionary again, this time setting green to red, then when you create another list from values, it's going to have blue and red. You can also, on the dictionary view, you can pass them into a len to get the length of the number of values or keys in the sequence. You can also do X in the view or X not in the view. And that will test whether X is in the keys or the values or the item pairs. Note that as of Python 3.7, the current version, these will always give you sequences that iterate in the order that the keys were added to the dictionary. In previous versions, you weren't guaranteed that it would be in that order, but it would be in a consistent order, meaning you could iterate across the keys and the values at the same time and be guaranteed that the key that you had next would be mapped to the same value that you got next. These methods will modify the contents of the dictionary by removing elements. You can call clear, which removes everything from the dictionary. You can call pop, and you pass in a key, and that will remove the key from the dictionary and return its value. If it's not there, it will raise a key error. You can also call pop with a default value, which will remove the key from the dictionary, returning its value. And if the key isn't there, it will return the default value instead and not raise a key error. You can also call d.popItem, which returns a key value pair from the end of the dictionary. If there is no elements left, that will raise a key error. There's several ways to fetch a value from the dictionary. We saw pop and popItem. but this destructively fetches from the dictionary. There's a couple ways to do it without destroying the dictionary in the process. You can call get, that's a T, with some key, and that will return the value for the key, or it will return none if it's missing. You can also call get with a key and a default value, which will return the value for the key or a default value if it's not present. There is also set default. Without a default value that it will set, it will return you the value of the key, and if it's not present, it will return none and set that key to be none. And finally, there's set default with a default value. What this will do is if the key is present, it will return the value. If it's not present, then it will create a key assigned to the default value and return the default value. D.update allows you to update elements of the key, allows you to update elements of the dictionary using the same syntax that the dict function uses. This is a great way to bring in lots of changes to the dictionary all at once. Finally, there's D.copy, which will create a copy of the dictionary. That's the same as calling dict on the D. I frequently use update and copy to create a dictionary that has defaults set, and the way you do this is as follows. So let's say we call the function dict from defaults. And we're going to pass in the defaults, and we're going to pass in the values of the dictionary. Basically the values that we want to specify for the dictionary. So we're going to create a new dictionary from the defaults. We have to copy that, obviously. So we're going to go defaults.copy. I'm running out of room here. And then we're going to update with the values that we passed in. And then finally, we'll return that new dictionary. So if the values weren't specified, the dictionary is going to have the defaults copied from the default dictionary. If they were specified, it'll override the defaults. Dictionaries are probably one of the most useful data structures in Python, and I use them almost all the time. You can use them to gather parameters for a function call. You can also use them as a cache. Because of its order 1 behavior, it's really useful as a cache. You can create additional namespaces. You can also use them as mappings or lookup tables. Okay. A good example of what I mean by that is you might have some kind of error code dictionary that when you pass in 404, it gives you not found. And that's a lot of the ways that I see that used. Another way to use it is as a poor man's switch statement. Switch is not found in Python as a statement. Many other languages have it. If you want to replicate somewhat the behavior of switch, what you can do is build up a dictionary that maps to functions that represent the code that you want to execute when that event occurs. A good example of that might be in some video games. You might have in your event loop there, when they press a key, you might have a mapping of what the keys are supposed to do. So if they pressed W, that's supposed to move the character up. If they pressed A, that's supposed to move left. And if they pressed S, that's move down. And then D will move them to the right. And you can remap these keys however you want. And when you go inside the event loop, what you can do is you can call key codes with the key that was pressed, and then you can execute that, and the code will be run. The key thing to remember about dictionaries is looking up a value for a key, adding a new key value pair, or removing a key from the dictionary is all order 1. This is very efficient behavior, even better than lists. There's a couple additional notes that I want to add before I let you go here. One is that you don't want to modify a dictionary while iterating. Don't do that. That can lead to all sorts of problems, especially a runtime error. So if you're iterating through a dictionary, don't modify it. If you need to modify a dictionary while you're iterating through it, just remember the changes you'd like to make in an additional dictionary, or remember the keys you'd like to remove, and then do that after you've done iterating. Another thing is that some people get confused, especially coming from certain languages. Keys are not the same as attributes. This is more, we'll talk about more about this when we get to object-oriented programming, but sometimes people see this kind of syntax and think that that's the same as this, but it's not. There's a difference between what's happening here and here. So try to keep in your mind that accessing the keys of a dictionary is not quite the same as object access. And finally, one more kind of rule of thumb is to get crazy with the keys. There's a lot of experimentation you can do using tuples as keys and using some other objects as keys as well. Get very imaginative and try out different things and see what works. Anyway guys, thanks for watching this video. I hope you enjoyed this. I hope you learned something new about dictionaries. Have a great day. Take care and bye-bye. Thank you for watching this video on the theory of Python by Real Physics. Be sure to subscribe and ring the bell, like and share this video. You can find me on Discord or support me on Patreon. Links are in the description below. Thank you so much. Have a great day. Bye-bye.